Okay, so for this lesson, we are starting with an introduction to radians as angle measures. So in every other experience you've probably had with angles, it's always been in degrees, right? So when you've been measuring angles, it's always been, oh, this is like 30 degrees or 40 degrees or 90 degrees, right? Where we're going to kind of switch that today is by looking at something called a radian, right, and where that definition comes from. And it's just a different way of measuring an angle. Instead of measuring it in degrees, we measure it in radians. Okay, so to start with, let's try and just kind of look at where this idea of a radian comes from, okay, just by recalling some basic facts we know about circles. So if you were to talk about a circle, how many degrees are in a circle?
360.
Right, so you do one rotation, you know that there's 360 degrees, right? If you started in one spot and went all the way around, there's 360 degrees in a circle, okay? Now, what's the circumference of a circle? What's the formula for a circumference? Because it's like the perimeter of a circle, right? So your circumference is 2 times pi times the radius, or you may have remembered it as pi times the diameter, right? Because 2 radius is the diameter, okay? So if we were to assume that a circle had a radius of 1 unit, okay? So here's our circle. Let's assume that the radius is equal to 1, okay? Then what would be the circumference of this circle? So if the formula is 2 times pi times the radius, and I'm telling you that the radius is going to be 1 unit, it's just going to be, it's just going to be 2 times pi times 1, which is 2 pi, right? So that means going all the way, if we started here and we went all the way around the circle, that's a measurement of 2 pi, right? Because going around the circle is the circumference. But we've also talked about the fact that going all the way around the circle is how many degrees? 360. So what that means is that 2 pi is equal to 360 degrees, right? So going all the way around a circle, right, is 2 pi, it's like the circumference, assuming that the radius is 1, right? And then going all the way around the circle, you have 360 degrees. So you can make this statement that 2 pi is equal to 360 degrees, or if you simplified that a little bit more, pi is equal to 180 degrees. Okay? So this is another way of representing angles. So instead of talking about 360 degrees, we'll talk about it as 2 pi. Instead of talking about 180 degrees, we'll talk about it as pi. What do you think 90 degrees would be? Pi over 2. Right? So using the fact that one rotation, right, one full circle is 360 degrees is 2 pi, you can then kind of use those fractions of a circle, right? A quarter of a circle, or a quarter of 2 pi is pi over 2, or 30 degrees is a 12th, and do that math that way, okay? So this is what we call a radian. So when you see measures in terms of pi, we call those radians, okay? So how do we actually define what a radian actually is, okay? One radian is defined as the angle between 2 points on a circle where the distance between those 2 points, like on the circle, this arc length aspect here, okay, is equal to the radius, okay? So if we have a radius of a circle here, where let's say this radius is 1, we know that we've measured 1 radian, where after we've rotated and we've done the same distance as the radius, the angle that we've moved is considered 1 radian. So you can extend that similarly, like let's say we had a different circle in which the radius was 2, okay? We reach 1 radian after we start here and we work our way until we've done a distance of 2. And then this is still 1 radian. Right? That's our definition, right? So if you were to look at just any sort of circle, right, how many radians do you think you can get? It's a little bit over 6, which is like 2 times pi, which is 6.28. Right? So on the clock that's in my classroom, right, this is actually, again, a circle where see how the color changes in the clock in every little section? Each of those is a radian. So this section here in yellow, that's 1 radian. This section here in purple, that's another radian. Right? In orange, that's another radian. Light blue, another radian. Light green, another radian. This other greenish color is another radian, and this little bit of extra. All right, so look how many radians are in that circle. 1, 2, 3, 4, 5, 6, and a bit. And where that's coming from is 2 pi, right? We talked about going all the way around the circle being 2 pi, where if you did 2 times pi, 2 times 3.14 is 6.28, right? So every circle has 6.28 radians in it, okay? So because of that, we can actually get an approximate degree value of 1 radian, right? So remember we talked about that 2 pi was the same as 360 degrees, right? We also said that that meant that pi was equal to 180 degrees. So if we wanted to try and figure out 1 radian, okay, we want to try and figure an approximate degree value for that, what we end up doing is we take our 1 radian and we multiply it by 180 degrees over pi. Okay? What we're essentially doing here is we're multiplying by essentially 1. Because if pi is equal to 180 degrees, if you put them over each other, it's just the same thing divided by the same thing, which is 1. So you're just trying to find a different way to do this. So if you were to do this multiplication, right, 1 times 180 over pi, you can get an approximate value of, let me just do that math, of 180 degrees divided by pi, approximate value of 57.3 degrees. Right? So 1 radian is approximately 57.3 degrees. And that's kind of what we're going to use here when we're converting between radians and degrees. Okay? So, again, if you were to look at this picture of this circle, right, every degree value also has a corresponding radian measure as well. Okay? Oftentimes given in terms of pi, right? So here at 0, right, we can then start by rotating counterclockwise. So from here to here, this is a rotation of 30 degrees, which is the same as 1 pi over 6. Okay? Where does that come from? So remember we talked about the fact that the circle has 360 degrees, right? 30 degrees is what fraction of 360? Right, so 30 over 360 is what? If we reduce it. How many times does 30 go into 360? It goes in 12 times, so it's like 1/12. Okay? Now remember we said that 360 degrees was also the same as 2 pi, right? So what we can do is say, okay, well, what's 1/12 of 2 pi? Right? So 2 pi times 1/12 ends up being 2 pi over 12, which reduces to pi over 6. Right? And that can essentially be done for every single rotation. Right? So if we do 60 degrees, so again, starting from this line, and we go this way to 60 degrees, right, that can also be rewritten as pi over 3. Once again, because 60 over 360 is 1/6 of the circle, and 1/6 of 2 pi is going to be 2 pi over 6, which is the same as just pi over 3. Right? So it can just be done in those aspects, right? So those are the key values that are going to have nice over pi's, right? Something like, 82 degrees isn't going to work out so nicely because it's not a nice fraction of 360, right? So then you'd have to get an approximation value, which is perfectly fine, okay? So how do you go from one to the other? If you have a degree value and you're trying to get it in radians, you just need to multiply by pi over 180. Right? So one nice example of that, like one that we didn't do, let's say we were given 45 degrees. Okay? So given the degree value 45, to convert that to radians, I need to multiply it by pi over 180 degrees. Right? So think of this as a fraction, 45 over 1, and you just multiply your fractions across. Right? So 45 times pi will be 45 pi, and 1 times 180 is 180. Right? Then you're just trying to simplify your 45 and your 180. So how can I reduce this? Does 45 go into 180, and if so, how many times? Well, what's 45 times 2?
4 times.
Yeah, so 45 times 2 is 90, and then how many times does 90 go into 180? Twice, so 2 times 2 is 4. So really, this cancels and this drops down to 4. So what we get is pi over 4. So this is your measure in radians here. So 45 degrees is the same as pi over 4 radians, right? Or if you wanted to get a decimal approximation there, you could just actually plug that into your calculator, pi divided by 4, and get that that is 0.785 radians. Okay, so there's just two different measurements there. If you're going the other way, right, so notice how with degrees to radians you're multiplying by pi over 180. If you're going to do a radians to degrees, you just flip that fraction here, right? So instead of doing pi over 180, you're doing 180 over pi. Right, so just depending on what it is that you're doing, right? So going the other way, let's say for a radian measure that you've been given, let's say 5 pi over 6, okay? That's the measure you've been given in radians. You want to turn that into degrees. You're going to multiply it by 180 degrees over pi, right? Because those are equivalent values. So it's essentially like multiplying by 1. So again, you're going to do that 5 pi times 180. And you get 900 pi divided by 6 pi, right? Your pi's are going to cancel here. And 900 divided by 6 is just 150 degrees. Right? So what you're essentially doing is being able to convert back between one unit and another. Right? So to go from degrees to radians, you multiply by pi over 180. To go from radians to degrees, you multiply by 180 over pi. Okay? So let's just do some approximations here. Right? So estimate the value of each angle in radian measure. So these are all actually nice ones that can be done using just a little bit of like proportional reasoning, right? So again, let's think about our circle, knowing that the entire thing is 360 degrees, right? So 0 all the way over to 360, right? What would this value be? How many degrees have happened at this point? 90, so we know that that's 90 degrees. We know that down here would be 180 degrees. Oh. So there's 180 degrees. What would this value be down here? 270 degrees. Okay, so there's your 270. So if we want to try and estimate this, again, remembering that this was all in terms of radians as well. So one full rotation was 2 pi, right? So this is equal to 2 pi. So what's this value here over at 180? Right, it's half the circle, so this would just be pi. And a quarter of the circle was half of pi, right? And 3/4 of the circle would have been 1.5 pi, right? So 3 pi over 2. Right, so this can help us in our estimations. So if we had to estimate the value of 90 degrees here in A, what would we say it is? Just by using our basic circle here, it's pi over 2. Right? And then if we wanted to get an approximate value for that, right, it's just that pi divided by 2 is 1.57 radians. Right? 45 degrees. Where's 45 degrees on that circle? Between 0 and 90 and exactly halfway between, correct? So if this is going to be where my 45 degrees is, and from 0 to 90 is pi over 2, what's this going to be as a fraction? So if this is half of the pi, this is half of a half, which is quarter. Right, so this would be pi over 4. Right, because if you're thinking about from 0 to 180, right, across here as like a single pi, and you cut this into 4 pieces, this is a quarter of it. Right, so that value of 45 degrees is equal to pi over 4, which again, you could calculate as an approximate value as 0.785 radians, right? And again, with that 150, right, a little bit harder to see there on that graph, right? But again, if you think about, okay, well, what is 150 as a fraction of the circle of 360 degrees, right? So 150 over 360, simplify that down, and it reduces to 5/12. Okay, both are divisible by 36, oh, sorry, not 36, both are divisible by 15, okay? Oh my gosh, even more than that. By 30, they're both divisible by 30, sorry. So you divide 150 by 30 to get 5, you divide 360 by 30 to get 12, right? So 5/12 of a circle is 150 degrees, so 5/12 of the 2 pi in terms of radians is going to be 10 pi over 12, right? Because you think about it, it's 2 pi over 1, you're just multiplying numerators and denominators, which can reduce to 5 pi over 6, right? So 150 degrees is that 5 pi over 6, which again can be estimated on a calculator as around 2.62 radians going around the circle. Okay? So again, you can go the other way as well. So estimate the value of, oh, this is the same way, sorry, but estimate the value of each angle in radian measure. Now these ones may not work as nicely. So again, we can use that trick that I talked about. If you're going from degrees to radians, okay, so again, so degrees converting to radians, you multiply by pi over 180, right? So it's like the thing that you want goes in the numerator, right? So if you're trying to get radians, put the radian value of pi on the top. If you're trying to get degrees, multiply by 180 over pi. So here, I would take that 240, so it'd be that 240 times pi over 180, so then that's 240 pi over 180, reduce your fraction, so both of those are divisible by 30, so that's going to be 8 pi over 6, which actually reduces again, both are divisible by 2, so 4 pi over 3. Right, so there's my value in radians. Okay, do the same thing here, that 450 degrees, multiply it by pi over 180. Right, so again, that's going to give you 450 pi over 180. Again, reduce your fractions. Again, both divisible by 30, so that could be 15 pi over 6. And then they're both divisible by 3, so 5 pi over 2. Right, could be your measure in radian. Okay, and then C here, you get 690 degrees. Again, you're going into radians, so you multiply by pi over 180. So you got your 690 pi over 180. Right, reduce. And again, both divisible by 30, so you get 23 pi over 6, and that doesn't reduce, so you're done. Okay, so radian measures are either given as values in terms of pi, or they're just given as like numerical values with no degrees on them, just decimal values. Okay, so these are all ones being left in like the form of pi. Okay, but they can always be converted into numerical value by just doing that division, right? 23 times pi divided by 6 and getting the approximate radian measure. Okay, so if we were to compare them, determine which angle is bigger, 3 pi or 8. Okay, both of these are measured in radians, right? So if you don't see a unit on it, you can assume that it's meant to be measured in radians. If you see the degrees, you know it's degrees, right? So this is like 3 pi radians, right, versus 8 radians, right? Now, if you had these in degrees, would you know which one was bigger? Yeah, so maybe that's our strategy here. Let's convert them both into degree measurements, and then we can see which one actually has the bigger degree value, right? So if we convert it into degrees, radians to degrees, you're multiplying by pi, you're multiplying by 180 over pi, right? So then multiplying numerators by numerators, right? So 3 times 180 would give you 540. So you get 540 pi here, and then 1 times pi is pi. So what's going to happen with those pi values, 1 in the numerator, 1 in the denominator, they're going to cancel, because if you're multiplying and then dividing by the same thing, it just gone. So that means that 3 pi is the same as 540 degrees, right? And if we looked at what 8 radians is, again, we can just take 8 over 1, still multiply it by that 180 over pi, right? So 8 times 180 is 1440 over pi. Do that division, right? 1440 divided by pi, and we get an approximate value of 458.4 degrees. Right, so now that they're both in degrees, which angle is larger, 3 pi or 8? 3 pi, right? Because when we did the conversions back to degrees, the 3 pi was 540 degrees, whereas the 8 radians was 458.4 degrees, right? So 3 pi is a larger angle than 8. Okay? And again, you could even like reference the clock in the classroom as well, right? Where 3 pi, so one full rotation is 2 pi plus another pi, right? Brings you all the way like one full rotation and again, right? Whereas 8 radians is like 1, 2, 3, 4, 5, 6, 7, 8, and we don't get to that point, right? Kind of looking at those pieces. Okay? So that's kind of how we do our conversions. So radians are a unit of measure that's related to like the circumference in the circle and the relationship between the angle that you rotate and the distance between the radius and the distance you're moving along the circle. And the relationship essentially is that 2 pi is equal to 360 or 1 pi is equal to 180 degrees. And we can do that conversion by either multiplying by 180 over pi if you're going from radians to degrees, or multiplying by pi over 180 if you're going from degrees to radians. You could also, again, go back and recognize that that one approximate radian was around 57.3. So another way to estimate that value of 8 would have been to say, okay, 8 radians here, right, times the 57.3 degrees, right, because that's what we measured 1 radian as, right? So you do the 8 times 57.3, and once again get that same value of 58.4 degrees. You can do it 2 ways, right? So you can either recognize the fact that 1 radian is approximately 57.3 degrees, or just always do that multiplication by 180 over pi, and you will get the same approximate value. Okay? And that's the lesson on converting between degrees and radians. Right? And then the questions here are the ones that I'd like you to practice to solidify that skill before we do anything else. Good?